we are on tape now. All right. What is the volume of 2.50 moles of gas at 26 degrees Celsius in 2 atmospheres with an R equaling 0.0821? And all the units go with that R. That liters times atmospheres divided by mole, also divided by Kelvin. All right, stay with me. What is the volume? So there's my question. That's what I'm looking for. When I have 2.5 moles, that's my N, 2.50 moles, and I'm going to abbreviate moles as MOL, at a temperature of 26 degrees Celsius. So I add 273, and when I add 273 to that, I get 299. Because this is to the ones place, that's what I do with my Kelvin. I take it to the ones place. And a pressure of 2 atmospheres. Okay, if you will do that, you then can cancel out your units with the R that I gave you. I gave you an R of 0.0821 liters times atmosphere divided by mole divided by Kelvin. So I've seen a Kelvin right here. I've seen a mole right here. And I've seen an atmosphere right here. So what do I get to circle that's left out of my R? I get to circle my liters, and that tells me what my unit's going to be. See, what we're doing is we're looking at a gas. The gas is confined. Obviously, it has to be confined, otherwise it would be escaping and moving all over the place. Gases do that. They're not attracted to each other. We're looking at its pressure and its temperature and how much of it we have to figure out what kind of volume container it has to be sitting in. That's what we're doing when we do this ideal gas law. So now what I'm ready to do is just take my numbers and plug them into this first equation called the Puvner equation. Okay? So I'm going to write down P, which is 2. So I'm doing this right here. I'll point. I'm doing this right here. P times an unknown V is equal to 2.50 times the constant R. R I gave you. I have to give it to you because you don't have to memorize it. And then the Kelvin temperature has to be Kelvin 299. There's my plug in the numbers without the units. I don't need the units anymore because I canceled out units. Yes? Okay. Divide both sides by what? If I want to isolate V, divide both sides by what? 2. 2. So you're right. Cut it in half, if you will. All right. To isolate V, I'm trying to solve for V. I divide both sides by 2. So when I go in my calculator and I say 2.5 times 0.0821 times 299 divided by 2, I get a value of 30.7 liters. So I get V is equal to 30.7. I'm rounding it to 3 sig figs. And then I go up here and I say, what did I circle? I circled liters. And that is my final answer, 30.7 liters. So I'm taking the numbers out of my problem and I'm plugging them into an equation. Today you're actually going to go online and do ChemThink for gases to try to help you understand why we even look at these gas laws, what these gas laws are really all about. They're trying to help us, Tyler. They're trying to help us with understanding pressure and volume and temperature for gases, also in this case with an amount. So this is a Puvner equation. The next one is not a Puvner, it's a P1V1 T2 equation. And why? If I have 2 volumes or 2 temperatures mentioned, it's going to be P1V1 T2. It's going to be the other equation. And I'm going to start keeping it linear. I think it'll help some of us with our math if I do that. Okay, you with me? All right, so I want to bring this up just a touch. Let's hope it doesn't go up too much. It did not. All right, this question says, if 2.30 liters of a gas at 30 degrees Celsius and 2.49 atmospheres is switched to a 3.40 liter container at 35 degrees Celsius, what is the new pressure? So my first time volumes mentioned, so he's the 1. First time temperatures mentioned, so he's a 1. First time pressures mentioned, so he's a 1. No sleeping. I heard you. V2 is equal to 3.40 liters. T2 is equal to 35 degrees Celsius. And P2, nope, P2 is question mark. Now, what do I have to do, Daniel, with my two temperatures? Maybe that wasn't fair. Daniel wasn't here last time, but Hunter was. Hunter, what do I have to do to my two temperatures? Thomas, what do I need to do?
Add 230.
Thomas? Add 273 to make them Kelvin. And I don't worry about this cutoff number. I go to the decimal place here, 1 decimal place. So that's 303.0 K. And this one down here, plus 0.273, is 308.0 K. Yes? Okay, so now I need to cancel out units. Now here I don't have an R to go cancel out with. I have liters and liters gone. I have Kelvin and Kelvin gone. So what unit do I get to circle? The ATM. I get to circle the ATM. I get to circle the ATM. Now all I have to do is take my numbers and plug them into that formula right there. Okay? So let me rewrite it for us. I think it might help if we see it down here. P2, V2, T1. Okay? So I'm going to plug in just numbers. So I'm going to plug in 2.49. And I'm going to multiply that by 2.30. And I'm going to multiply that by T2, which is 308.0. Everybody see that? Okay, see if I can write tiny for this other part. We're looking for P2, so I'm going to write it like that, P2. My V2 is 3.4, and my T1 is 303. I can write small. All right, is everybody with me? Lauren's with me. Thomas is with me. Juan is with me. Okay, divide both sides by 3.40 and 303. 3.40, shh. Still got to zip it. Okay, so that those numbers go away, and I have isolated what I'm looking for, which is my P2. Yes? Yeah. Okay, I get an unrounded answer of 1.7122, and I round that to 1.71 atmospheres. That's my P2. Now, you might not have gotten the right math because you might have said that times that divided by this times that. No. No. So if you did not get the right answer, let's do this in steps. Let's do the top part first. We would have to say 2.49 times 2.30 times 308.0 is. And I get a value of 17639, 176.3.9. That's my top number. And then those two numbers on the bottom multiplied, 3.4 times 303.0 is 10302, 103.0. And now, if I say 1.763.9 divided by that number, I get something it doesn't like. 1.763.9 divided by 1030.2. Why doesn't it like that? 0.9 divided by 1030.2. And I get 171,219 So I get very close to what I had here. That rounds to this. So if you can't do this, because you're getting a wrong number, then multiply everything on the top and get that. Multiply everything on the bottom and get that. And then go do your math to get the correct pressure. Your correct P2. Okay, is everybody with me?
What's the thing in the box?
I just told you. What is the thing in the box? I was trying to write really small. It says P2. P2 times V2 times T1.